Okay, in this video, we are going to be looking at the fraction word problems page that is on page 236. So in my last video, I said you would be having a quiz over fraction operations very soon. It's actually next week. So page 236 would be a great study guide or practice for you as you prepare for that quiz. So essentially in that quiz, I am just going to give you a word problem. You will have to figure out whether it's addition, subtraction, multiplication, or division. And then you will have to draw me a picture to solve the word problem. Okay? So the hardest part is just figuring out which operation is happening in these word problems. So what I would like for you to do first on page 236 is to go ahead and just try these problems on your own. So try 1 through 8, attempt them, pause this video, and then when you're done, come back so you can check your answers to your work. Okay, so let's maybe review a little bit first. Okay, so to review, before we try these, or before you check your answers, so just think about the 4 operations that we have. Okay, so then we have multiply and divide. Okay. So key things you should be looking for. So with addition and subtraction problems, remember that it's always a fraction of a whole thing plus a fraction of a whole thing, or it is a fraction of a whole thing minus a fraction of a whole thing. And those labels have to match. Okay, match. So for example, it's going to say something like cups plus cups equals, and the answer has to be in terms of cups. Same thing with subtractions. You have cups of something, you take away cups of something, it equals cups of something. So the difference is with multiplication. With multiplication, remember it's always a problem with groups times a size. So typically with these problems, it's going to say something about groups, or it's not necessarily a label for the starting quantity. So remember if we said something like we have 2/3 of a cake and then we eat half of it. So of it isn't really a label, but with multiplication we are doing a fraction of another fraction instead of a fraction of a whole and a fraction of a whole. Okay, oh, there's my cat again. So there isn't necessarily a label for the first one. And remember, multiplication is also different because we always draw the second number first so that we can take a fraction of whatever we have to start with. With all of the other quantities, with addition, subtraction, division, we always draw our starting quantity first. And then with division, division typically has 2 different labels, and there's 2 ways of doing division. So remember, as in the last video that we just looked at, you could have a partition situation where partition, let's see, from the last one, we said something like we had cups being divided into batches, and the answer is in terms of cups. So the 2/3 of a cup of raisins over a half of a batch of cookies. Or it can be measurements, and in terms of measurements, we had, let's say one example was 9/10 of a pound of meat divided into 2/5 of a pound per sandwich, and then our answer is in terms of sandwiches. Okay, so typically when we are doing division, you will see 2 totally different labels. Okay, now sometimes that will happen with multiply, so we just have to be careful, but 99% of the time, if you see two different labels, it's probably going to be division. Okay, so how did you do on these problems? So you should notice all of these problems have to do with 2 1/3 and 3/4. So just to show you that there are several different ways that you can use the same facts in order to do problems. Okay, so with number 1, after his birthday party, Corey had 2 1/3 pizzas remaining, and this morning Corey ate 3/4 of the remaining. So when you see of the, so of what is left over, that should tip you off that that is a multiplication problem. So he is eating 3/4 of, what does he have? 2 1/3 pizzas. So that one is multiplication. So it tells you to solve these by drawing a picture. So we would start with, we would have 2 1/3 pizzas. So let's try this. So 2 1/3 pizzas. And then we want 3/4 of the remaining pizza. So if we split each pizza into 4 parts, kind of made this really tiny. So 3/4 would be that much, 3/4 is that much, and then 3/4 is that much. So to get our answer, we need same size pieces. So we have, right now we have 4ths and then 12ths. So go ahead and chop everything into 12ths. And our answer would be 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 pieces. And there are how many pieces in one full pizza? There are currently 12. So answer should be 21/12. Okay. So we're not doing this part about using an algorithm. Okay. All right, number 2. Selena has 2 1/3 pound of bird seed, 2 1/3 pound bag of bird seed. Her bird feeder holds 3/4 of a pound of bird seed. So after she fills her bird feeder, how much does she have left? So keywords here, has left, and it's a pound of the bag and a pound of the bag. So labels are exactly the same, and if it's asking for how much she has left, that should tip you off. This one is subtraction. So 2 1/3 minus 3/4. And we're actually doing an action. We are taking away the bird seed. So I should see in your picture taking away, not a comparison. So again, we would start with 2 1/3. So this one, let me just use my pen. Okay, so 2 1/3. So we would have to show that we are taking away 3/4 of a pound. So that means take one of the pounds, split that into 4 parts, and then we are going to take away 3 of those 4 parts. So let me color them with a different color. So that is what's being taken away. So what do we have left? We have 1/4, a whole, and a 1/3. So to get our answer, let's again make same size pieces. So split that into 12ths, split this one into 12ths. So we have 1 full pound left, plus 1, 2, 3, 4, 5, 6, 7 pieces. It's kind of hard to see, but 7 pieces left. And there are how many pieces in 1 pound of bird seed? There are 12. So answer to this one should be 1 7/12. Okay. In number 3, it says Max needs 3/4 of a cup of pasta for every serving of salad. So how much pasta does he need to make 2 1/3 servings? Okay, so this is one where you might be tempted to say it's division because we have cups and we have servings. But if we think about the context of this problem, is it saying that I have 2 1/3 like groups of something, and then I'm splitting them up into a size of 3/4. Am I taking 2 1/3 and then saying like, okay, 3/4 is here, 3/4 is here, 3/4 is here? No. So this is not division, this is actually multiplication. The servings are like groups. So if it's 3/4 of a cup per serving, so group, and we want 2 1/3 servings or groups. So we want 2 1/3 servings or groups of size 3/4. Okay, so 2 1/2 times 3/4. So a picture of this, we would need one full group of 3/4. Okay, so let's see what that looks like first. Then we need a second group of 3/4. And then we would need a third of a 3/4. Okay. Okay, so one full group of 3/4 would be all of this. The second full group of 3/4 would be all of this one. And then we only need a third of the 3/4. So what's nice about this one is 3/4 is like 3 pieces. So a third would be one of those 3 pieces. So our picture would look something like that. So what do we have? We have 1, 2, 3, 4, 5, 6, 7 pieces. And it takes 4 of those pieces to make a full cup. So our answer should be 7/4 of a cup. Okay. All right. Number 4. A serving is 3/4 of a brownie. So how many servings can be made from 2 1/3 brownies? All right. So this one again has brownies and servings. So again, is it like the last one? Are we trying to make groups of a particular size? Are we trying to make groups of 3/4? No. So in this one should hopefully make some sense to you because maybe you've done this before. So if you had 2 1/3 brownies, you're going to chop them up into 3/4 of a brownie per serving. So like 3/4 would go to this friend, 3/4 would go to this friend. So this one is division. And which type of division is this? Is this partition or measurement? So we are making a particular sized brownie. So this is going to be measurements. So I'm just going to put M for measurement so you know. All right, so what is this going to look like? So we have 2 1/3 brownies. All right, so that's the brownies we have. And then maybe it would help, again, if you knew how big 3/4 looked like, what a serving looked like. So I'm going to chop it the other way. So here's what a serving would look like. So a serving is that big. So certainly on this one you could start with, okay, chop the first brownie up. So you would take 3/4 of it, and that would be serving number 1. So right there. And then you could chop this brownie up as well into fourths and take 3/4 of it. That would be a serving also. That would be like serving number 2. But then we still have like this slice, and this slice left in order to see if we could make another serving. So again, since this is fourths, this is thirds, this is fourths, this is fourths, it'd be nice if they were same size pieces. So let's chop these up into this one into thirds, this one into fourths. And then this one would also get split into thirds. Okay, so now it's going to take 9 little squares to make a serving, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So these 9 are going to make another serving of brownie you could give to a friend. So that would be serving number 3. So we have 3 full servings. And then how much of another serving? We still have this one little square left. Out of how many does it take to make another serving? It would take 9 of them. So our answer for this one should be 3 1/9. Okay. Okay. All right, number 5. We're halfway there. Number 5. Emily has 2 1/3 pies. She has 3/4 more than Bobby. How much pie does Bobby have? Okay, so in this one, Emily has 2 1/3 pie, and she has 3/4 pie more than Bobby, and her answer is how much pie. So we have pie, pie, and pie. So that should tip you off that this is either addition or subtraction. So let me just highlight these for you. And I could have done that, I guess, in the last one that we had brownies and servings. 2 different things. Let's see. So she has more pie than him. So to figure out his amount, we would have to do some subtraction. So we're going to do 2 1/3 minus 3/4. And technically this is a comparison problem. So you can try and do comparison. Let's see if we can attempt to do comparison. See what our answer might be. Okay, so starting with, what does Emily have? So Emily, we know, has 2 1/3 pie. Okay, so okay. So if she has 3/4 of a pie more than Bobby, what would Bobby's pies look like? So Bobby would have like this. If he had 3/4 less, oh sorry, I didn't realize this was looking kind of weird, crooked on my video. I apologize. So if he has 3/4 left, you could split one of Emily's pies into 4 parts, and then he would have 3, he would be missing 3 of those 4 pieces, right? So he would only have 1/4 of the pie. Does that make sense? So if she has 3/4 more, this is the part she has more than him, and then everything else is the same. So we can figure out what Bobby's total is going to be. So he has 1 full pie, and then a pie that is split into 4ths and a pie split into 1/3. So let's make those same size pieces. So if you cut the other 2 pies into same size pieces, he would have 7 slices of a pie that is now cut into 12 pieces. So Bobby has 1 7/12 pies. Okay. All right, now number 6. Danny has a, well, that shouldn't say Danny has a. Danny has 2 1/3 bags of candy. Each candy jar holds 3/4 of a bag of candy. So how many times can he fill his candy jar? Okay, so we have bags of candy, and we have a jar, and our answer, how many times can he fill the jar? So that should tip you off that this is division. So think about, we have 2 1/3 bags, and we're dividing it up into these jars, and each jar holds 3/4 of a bag. So it would be 3/4 in this jar, 3/4 in this jar, 3/4 in this jar. So the 3/4 is the size that we're putting in each jar. So again, this one is going to be measurement. So just to save ourselves a little time, this one was also 2/3 divided by 3/4 in measurement. So the picture is going to look exactly the same. So you would start by drawing 2 1/3, and then you would figure out how big 3/4 is. So that's the jar. So then here's one group of 3/4, here's a second group of 3/4, here's a third group of 3/4. So I am not going to redraw that because it's already drawn up here. So I'm just going to write same picture as number 4. So I hope that's okay with you and you understand why I am doing that, since they are both the same. Save a little time. All right, number 7 says I have 2 1/3 cakes and they fit exactly into 3/4 of a container. How much cake will fit into one container? So again, we have 2 different labels. So we have cakes, containers, and our answer is how much cake will fit in a container. So if we are trying to jam 2 1/3 cakes into this group, this is also a division problem. So this is 2 1/3 divided by 3/4. And in this one, the 3/4, it's not like we are doing what we did previously. So it's not like here's a 3/4 in this container, here's a 3/4 in this container. This is just one part of a group. So this one is going to be partition. So we should get the same answer since it's the same problem, but the picture is going to look a little different. So this picture is going to look especially weird. So let's see. So let me start this time with thinking about the container. Normally I tell you not to draw the container first, but I think it will make more sense if I draw the container first. So let's see. Here's our container. And let's say, oh, I have to split this into fourths. Why don't I do it like this? Okay, so there's the fourths. So my 2 1/2 cakes have to fill up 3/4 of the container. Okay, so how am I going to do this? Okay, so I'm realizing I made my rectangle too large, but that's okay. All right, so this is 3/4 of the container. So I need 2 full cakes. So let's say here's cake number 1. Here is cake number 2. And then we need 1/3 of a cake in the rest. So this is going to go into the words, but think about there would be another cake right here, and only 1/3 of this cake would be inside of the container. Okay, so again, I know this is kind of weird thinking, but okay, here's our cakes. Okay, so then how much cake could fit in the full container? So here's the way that I would think about this. So how much cake is in this container? You have 1/3 of a whole cake, 1/3 of a whole cake, and then you have this 1/3 of the 1/3, which is 1/9. So then here you would have, this is 1/3 of a full cake, 1/3 of a full cake, and then this little 1/3 of the sliver of the cake. And this is 1/3 of a full cake, 1/3 of a full cake, and then a sliver of the 1/3 of the cake. So what would also fit over here? This would be 1/3 of a full cake, 1/3 of a full cake. So think about another, the rest of this cake would be like extending outside of this box. And then again, you would have a like sliver of another cake just kind of hanging out in this box right here. Okay, so again, I know partitioning is weird. So what do we end up having? So in this cake box, or this container, we have this full cake, this full cake. And then we have, what else? We have 1/9, 1/9, 1/9. So another 1/3 is right here, right? This is 1/3 of a cake. This is 1/3 of a cake, and this is 1/3 of a cake. So these 3 pieces that make 1/3 plus this 1/3 plus this 1/3 should make 3 full cakes. So cake 1, cake 2, cake 3. And then you have this one little piece right here, which is 1/9 of another cake. So 3 and 1/9. So just know I'm not going to ask you any division, partition, fraction questions on your quiz or test. So if I do decide to do partition, it would be a whole number because that's easier to do. So don't worry too much about this if you don't quite understand. All right, and then finally the last one, I used 2 1/3 feet of blue yarn and 3/4 of a foot of yellow yarn. How many feet of yarn do I have in all? So in all is the keyword, so that should tell you you are doing addition. So this one is 2 1/3 plus 3/4. So a picture, you would draw 2 1/3. And then you would combine that with 3/4. So there's 2 1/3 and 3/4. Add them together to see what you get. So again, we would need same size pieces in order to compare those. So cut that into thirds, cut this one into fourths. And what do we have? So some intermediate work. We have 2 full feet of yarn. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 little pieces. And it takes 12 of those pieces to make a foot. So 13/12 would actually be 1 full foot. If you took 3 of these little squares and move them over here, you would have 1 full foot plus the 1 piece left. So we actually have 2 plus 1 1/12. So answer would be 3 1/12. Okay, so hopefully you got these correct. And if not, you can see what mistakes that you made. So as I said, next week you will be taking a quiz over these fraction word problems. So just keep practicing this week.